Hello, I'm Cody. This is my partner Henry, and this is our chemistry video. We have Mentos reacting with cola, Coca-Cola, beverages.
So our materials, we're gonna have like 4 different experiments. First one is gonna be Fanta with these fruity Mentos, 12 of them, and then our second experiment is gonna be the fruity Mentos with this Coke, and our third is gonna be the mint Mentos with this Fanta, and then fourth is gonna be mint with the Coke, and then we're gonna use a duct tape to hold down the drink so they don't like spill everywhere, and this little contraption to
drop them in
the like that. And then this drone over here, we're gonna use that to film the height
of the explosion. Our hypothesis for this is if Mentos react with a beverage, we believe that mint Mentos will have the highest explosion with regular Coca-Cola, based on previous knowledge, and fruity Mentos and orange Fanta will have lowest explosion. To know how these reactions work with Mentos and our different types of soda, we know that carbonated beverages contain CO2 gas and form bonds with the water inside. When the soda is just sitting in its container by itself, the gas is being kept in a solution by the carbonation in high pressure. However, the CO2 gas is released when it's poured into a glass, and I'll demonstrate. And you know that the CO2 is released when you pour it in and you see the bubbles and the foam form at the top, which means it means that the CO2 is being released, but most of it stays trapped in the solution from the soda's surface tension. To create the foam and the bubbles that form at the top, the CO2 needs to react with itself, meaning the bonds it has with the water inside need to be broken, and they're broken as they're poured into the drink, and different methods to make the CO2 release faster, and the Mentos do so, and is explained by Henry later on in the video. In addition to the explosion, the aerobic gelatin in the Mentos, the potassium benzoate, sugars, and aspartame, which is found in diet sodas, also quicken this reaction because these ingredients lower the surface tension, which allows the CO2 to release even quicker at a much faster pace, which allows a much higher explosion in reaction. Alright, this is the third part of the experiment with regular Mentos and our orange Fanta. That is very explosive. I'd almost say that's less than the strawberry Mentos and the regular orange Fanta. This is the fourth part of our experiment with regular Mentos and regular Coke. Okay, much quicker reaction, dang. Alright, so this is our big experiment. We got we got a 2-liter and we got 2 packs of Mentos in here. So mint Mentos. Alright, ready? I don't know if I'm ready. Oh God! Oh God! Jesus!
Oh God!
Jesus Christ, Cody! Did you get them all in?
Yeah, I got them all. Alright, so in conclusion, our hypothesis was supported because the mint Mentos with the regular Coke had the highest explosion, but what we did not expect was that the mint Mentos with the orange Fanta had the least reaction. Yeah, had the worst reaction, and not much came out as an explosion.
And the reason for this, the Coke reacting with the Mentos the best, is what we found out. We researched the nucleation theory. They're like actually the surface of the Mentos are actually like filled with really, really tiny holes, and as they go into the drink, they're like filled with a bunch of little CO2 molecules, and then just like getting filled by the holes. And as the Mentos drop to the bottom, the bubbles will like get released from the Mentos, and then they'll rise to the top, and they all rise like really quickly, which causes the explosion. And so I guess that works best with Coke because they have like an abundance of CO2 in it, and it's just the best resin. And it's just two reactants forming a reaction, and it's just a cool experiment that we started.